So for the first activity entitled Physical. Hi everyone, my name is Camille Sosa. So for today's video, I'm going to discuss about the topic in chapter 5. So if you're interested in this chapter, please keep on watching. So for chapter 5, CNA, Introduction to Networks, chapter 5 discuss about Ethernet. So, so OSI physical layer provides the means to transport the bits that make up the data link layer frame across the network media. Ethernet is now the predominant LAN technology in the world. Ethernet operates in the data link layer and the physical layer. So, Ethernet is defined by the data link layer and physical layer protocols. Media access control, the second responsibility of the MAC sublayer is the media access control. Media access control is responsible for the placement of frames on the media and the removal of frames from the media. And its name implies the controls access to the media. This sublayer communicates directly with the physical layer. So the CSMA process is used to first detect the media is carrying a signal. If a carrier signal on the media from another node is detected, it means that another device is transmitting. The MAC addressing is added as part of the layer of 2 PDU. An Ethernet MAC address is a 48-bit binary value expressed as 12 hexadecimal digit, 4 digits per decimal per digit. The MAC address is often referred to as born in address. The address is encoded into the ROM chip permanently. It cannot be changed by the software. It is possible to change the MAC address in software. This is useful when attempting to gain access to a network that filters based on via filtering or controlling traffic based on the MAC address no longer as secure. At the data link layer, the frame structures is nearly identical for all speeds of Ethernet. The Ethernet frame structures adds headers and trailers around the layer, 3 PDU to encapsulate the message. Both the Ethernet standards define the minimum frame size as 64 bits and the maximum of 1518 bytes. This includes all bytes from the destination MAC address filled through the frame check sequence field. The preamble and start frame delimiter fields are not included when describing the size of the frame. Any frame less than 64 bytes in length is considered as collision fragment. A host with IP address 192.168.1.5 source requests a web page from the server at IP address 192.168.1.200 for a unicast packets to be sent and received. A destination IP address must be in the IP packet header. A corresponding destination MAC address must also be present in the Ethernet from header to the IP address and the MAC address combined to deliver data to one specific. As with the unicast broadcast addresses, the multicast IP address requires a corresponding multicast MAC address to actually deliver frames on a local network. The multicast MAC address is a special value that begins. As with the unicast and broadcast address, the multicast IP address requires a corresponding multicast MAC addresses to actually deliver frames on local networks. The multicast MAC address is the specially value that begins with 01005E in a hexadecimal. The remaining portion of the multicast MAC address is created by converting the lower 23 bits of the IP multicast group addresses into 6 hexadecimal characters. Both the physical MAC and logical IP addresses are required for a computer to communicate on a hierarchical network. Just like both of the name and address of the person are required to send a letter. And devices on an Ethernet network do not accept the process frames based on IP addresses. Rather, a frame is accepted in process based on the MAC address. On Ethernet network, MAC addresses are used to identify at a lower level and source and destination host. IP packets in a data flow associated MAC address on each link along the path to destination. This is done through a process called Address Resolution Protocol. The ARP protocol provides basic function resolving IPv4 address to MAC, maintaining a table and mappings. When ARP receives a request to a map on IPv4 address to a MAC address, it looks for the catch map in its ARP table. If an entry is not found in the layer 2 process, notify ARP that is need to map. The ARP process then send out an ARP request packet to discover the MAC addresses of the destination device on the local network. If a device receiving the request has the destination IP addresses, it responds with ARP reply. A map is created in the ARP table. Packets for that IPv4 address can now be encapsulated in frames. The destination of IPv4 host is not in the local network. The source nodes need to deliver the frame to the router interface, that is the gateway or next hop used to reach the destination. The source node will use the MAC addresses of the gateway as the destination addresses for frames containing an IPv4 packets addressed to hosts on other network. Commands may also be used to manually remove all or some of the entries in the ARP table. After an entry has been removed, the process for sending ARP request and receiving ARP reply must occur again to enter the MAC ARP. In some cases, the use of ARP can lead to potential security risks. ARP spoofing or ARP poisoning is a technique used by the attacker to inject the wrong MAC address association into a network by issuing fake ARP replies. An attacker forgets the MAC address of a device and then frames can be sent to a wrong destination. Switches provide segmentation of LAN, dividing the LAN into independent collision domains. Each port on a switch represents separate collision domain and provides the full media bandwidth to the node of nodes and connected on that port. A layer 2 LAN switch performs switching and filtering based on only the OSI data link layer, MAC addresses. A switch is completely transparent to network protocols and user application. A layer 2 switch builds a MAC addresses table that it uses to make forwarding decision. Layer 2 switches depend on the routers to pass data between independent IP. Switching use MAC addresses to direct network communication through their switch fabric to the appropriate port towards the destination node. The switch fabric is the integrated circuits and the accompanying machine programming that allows the data pass through the switch to be controlled. For switch to know which port to use to transmit a unicast frame, it must first learn and which nodes exist on each of its ports. Half-duplex communication relies on unidirectional data are not performed at the same time. A full duplex communication data flow is bidirectional, so data can be sent and received at the same time. The bidirectional support enhances performance by reducing the wait time between transmission. Most Ethernet, Fast Ethernet, and Gigabit Ethernet solves today offer full duplex capability. Switch that detects the required cable type for copper Ethernet connections and configures the interfaces accordingly. Therefore, you can use either crossover or straight-through cable for connection to a copper. The Auto MDIX feature is enabled by the default on switches running Cisco iOS release 12.2 SE or later for releasing between Cisco iOS. In store and forward switching, when the switch receives the frame, it stores the data in buffers until the complete frame has been received. During the storage process, the switch analyzes the frame for information about its destination. In this process, the switch also performs an error check using the cyclic redundancy. In cut-through switching, the switch acts upon the data as soon as it is received, even if the transmission is not complete. The switch buffers just enough of the frame to read the destination's MAC addresses so that it can determine to which port of forward the data. The destination MAC address is located in the first 6 bytes on the frame following. The fast-forward switching offers the lowest level of latency, immediately forwards packets. There may be times when packets relate with errors. Latency measured from the first bit received to the first bit transmitted. Fragment-free switching switch stores a 64 bytes frame before forwarding, comprised between store and forward switching and fast-forward switching, most network errors, collisions. As discussed in a switch, analyze some all of packets before it forwards to the destination. Fixed versus modular configuration. A fixed configuration switches are fixed in their configuration. What that means is that you cannot add features and options to that switch beyond those that originally came with the switch. The particular model you purchase determines the features and options available. Modular switches offer more flexibility in their configuration. Modular switches typically come with different sizes, chases that allow for the installation of different numbers of modular line cards. A LAN 2 switch performs switching and filtering based on only outside data link layer. However, a layer 3 switch can also learn which IP addresses are associated with its interface. This allows the layer 3 switch to direct traffic throughout. The Cisco Express Forwarding, or CEF, decouples the usual strict independence between layer 2 and layer 3 decisions. Forwarding IP packets can be slow. The constant referencing back forth between layer 2 and layer 3. Cisco networking devices support a number of distinct types of layer 3. A layer 3 interface is one of that supports forwarding IP packets towards the final destination. The switch virtual interface locally interface on a switch associated with a virtual local area network. A switch port can be configured to a layer 3 routed port behave like a regular router interface. Configure routed ports by putting the interface into layer 3 mode with no switch port. Interface configurations command assign an IP address to the ports that's it. There are two styles of Ethernet framing, Ethernet standards and DIX Ethernet standards, which is now referred to Ethernet. 2. The most significant difference between the two standards is addition of a start frame delimiter and the change of type data type field of length field in 802.3 Ethernet. 2 is the Ethernet frame. So, thank you for watching this video. I hope you enjoy listening to my discussion, and I hope you learn something about this topic about Ethernet in chapter 5. I hope you will continue watching my video and let's learn together. That's all. Thank you.